So let's go over the worksheet number 11 here. Well, this section, we do have the title given to you here, but I do want you to keep thinking when and why do we use logarithmic differentiation. So when we have a lot of problems squeezed together, you can make the decision very efficiently. So if you look at this problem, I have a base, which is not a constant, so it cannot be exponential function. I have an exponent, which is not a constant, so I cannot use a power function to work this out. So having variable on the base and the exponent means my only option is to use logarithmic differentiation. So first step is take log on both sides. So what you end up with is ln of x times ln x. So move the ln x out in the front, so you have ln x and then keep ln and then keep your base. Well, you can simplify it a little bit further if you want to write it as ln x squared, but you don't have to. So once you took ln, like I said, once you took ln on both sides, the next thing you're going to do, you're going to take derivative on both sides. So you have ln of f of x, and then you have ln x times ln x. So the left side, according to the rule, you end up with 1 over f of x, 1 over whatever comes behind the log, because the log function has a sort of 1 over what behind it. Chain rule says you want to multiply by the derivative of the inside layer, and then the right side is product, so use product rule, which means you end up with something that looks like this. And then the rest part is just a matter of calculation. So you end up with 1 over x times ln x plus ln x times 1 over x, which you don't have to simplify, but if you really want to, this is equivalent to that. So your last step is to find out what's f prime of x. So it is 2 ln x over x. You want to multiply the denominator on the right side, right? So this is what you end up with as your final answer. So similar idea, it's a variable base, variable exponent, so your only idea is to take ln on both sides of your expression, so you don't have a power of tower to work with. What you end up with is a function that looks like this. Then you take derivative on both sides, so ln f of x takes derivative, is a multiplication of two functions put together. And then what you end up with is f prime of x over f of x, which is the derivative of the first term times ln of second, and x to 10, and then ln of ln x prime. So what you end up with is 10x to the 9 times ln of ln x plus x to the 10. Well, this is a log function, so the derivative is what derivative comes behind it, and then over that thing itself. So, well, I can find that pretty easily. So let me add a side note. It's 1 over x. So I can get my final answer is just whatever I have, multiply f of x to it. It's a good idea to have a bracket around it, so you understand the term should be treated together. Otherwise, it's going to be misunderstood. And then you have x to the 10 times 1 over x over ln of x. Okay, so this, oh, my bad, very sorry. It is plus here, right? So that's my final answer. And then next thing, I have the two functions down here. Well, technically you may say, okay, the last step is division, the last step is division. So I can nicely use just quotient rule to solve it. But if you just think about it in a little bit long term, those expressions you end up with here, they are technically what? They are functions that, they are the functions that they have to use multiple rules, product rule multiple times, so it's too hard to work out. Instead, if you use logarithmic differentiation, so apply ln to the right side, whatever comes behind multiplication is going to be changed into summation, so it makes the thing that pretty straightforward, right? And everything on the denominator is going to be subtracted, so you end up with, and I can keep simplifying because power structure can be thrown out, so it makes the structure pretty straightforward, and then minus 1/2, and then ln, and then x minus 1. Okay, so this is what we end up with, and now let's begin to take derivative. The left side is f prime of x over f of x. The right side is 8 times the derivative of ln x. plus 3 times the derivative of ln. So it's cosine of 2x plus 1 takes the derivative over itself, and then minus 1/2 multiply x minus 1 takes derivative over itself, which is 8 times 1 over x, plus cosine of the function. It is a composition, it's not a product, so I'm going to use chain rule. Chain rule says you take derivative of outside layer, so it's a negative sign, and then you substitute the inside layer into it, multiply the derivative of the inside layer, and then you have cosine of 2x plus 1 minus 1/2, and then 1 over x minus 1. It's quite obvious this term is 2, so I can merge two steps in together. I have that, I have 8 over x, I have minus 3 times 2 times sine of 2x plus 1 over cosine of 2x plus 1 minus 1 over x minus 1. Be careful, you want to get rid of the denominator from the left, so you multiply the whole thing to the right, so you need a bracket to hold things together. I have the same argument for the following problem. It seems like quotient rule is going to work, but when you use quotient rule and try to find the root of that term, it's not going to work out because it's a power of tower. So actually for this one, you still need to use logarithmic differentiation. So you're going to take log on both sides of the expression, and then every multiplication is going to be changing summation. But if terms are on the denominator, you are going to have negative sign. So it's x times ln x plus every single term we just write because there's no more simplification that can be done. Then let's take our derivative. The left side is f prime of x over f of x. This is product rule. So once we have this, the next thing is I try to work on the derivative of this term, which is in log, so it's cosine of 2x takes derivative over itself, and then my next term is minus, again it's ln of something, so it's sine x prime and then sine x, and lastly it's the same thing, you have ln of 2x prime over ln 2x. So what we end up with is 1 times ln x plus x times 1 over x. Cosine 2x, it's a composite function. Cosine generates negative sign, and then you substitute the inside layer of it, and then you multiply by the derivative of the inside layer, which by the way would be 2 later, right? And then minus cosine x over sine x, and then minus and ln of something, the derivative is whatever comes behind the ln over itself, ln of 2x. So I can easily identify my final answer, which is ln x plus 1, and then minus twice of sine of 2x over cosine of 2x, minus cosine x over sine x, and then minus 2 over 2x. So it's after simplification, it's 1 over x times ln x, and don't forget what you want to do is also want to get rid of the denominator. I mean, technically it should have been like this, right? So I want to get rid of it, so I multiply it to both sides. So this is my final answer. Okay, so hopefully you had a chance to go over those problems without listening through my hint and work those out correctly. So that means you have a good understanding of the logarithmic differentiation.